So yeah, as I've been introduced, welcome to this introduction lecture to Istio and Service Mesh. My name is Antonio. I'm a DevOps engineer at the workshop. And if you notice that I'm a little bit nervous or if I do weird gestures, indeed, I'm nervous. So feel free to laugh at me whenever you see fit. And without further ado, let's begin. So what are we going to talk about today? First off, the concept of service mesh, what it is, what is this technology is about, what this paradigm help us do, and afterwards I'll be talking about Istio as an implementation of this concept of service mesh, and later on I'll grasp a little bit about the trends and what the industry is heading to with regards to these technologies. And I will also like to clear out the goals of this talk so that nobody gets disappointed. And this talk is a little bit conceptual. I won't be doing any proof of concept or something or showing a specific use case. What I want you to be able to do at the end of this talk is to be able to answer these questions or some questions alike. For instance, to be able to answer what a service mesh is. Is it the right solution for the problem I have in hand, or whether Istio is the right tool to achieve the goals we have or the requirements we have? And all right, cool. Let's begin. Let's try to answer the question what a service mesh is. And before doing that, I would like to introduce you to some preliminary concepts to pave the way to understand this technology. The first one is reverse proxy. Probably you've heard of it before. It's just an architecture, a paradigm whereby we place a proxy between our application and the network where the traffic comes from. The purpose of this is to have some specific network features like TLS termination, caching features, security against denial of service kind of attacks, for instance, or better observability in terms of network. For instance, getting metrics about HTTP requests or better tracing. And the purpose of this is decoupling certain features that the application shouldn't be responsible of. The application, after all, should hold responsibility of the business logic, of the actual value that we are providing to our company, to our project, to customers, and those features that we as an operators would like to have, like TLS termination, for example, the proxy should be responsible of that. The application shouldn't be aware of that. So, okay, let's have this concept clear in our minds. Then let's assume we have now a set of services. When I mean services, it can be a set of virtual machines, it can be a set of applications. Just think of it as a distributed system, a set of processes, virtual machines, whatever. And then those services interact with each other, they communicate with each other, and one might think, okay, I would like to have those network features that we talked about recently for each one of those services. Okay, one might think, cool. Let's do that. Let's place a proxy in front of each one of those services, processes, again, virtual machines. What do you think of this? Do you think this is scaled properly? Honestly, I wouldn't be the one responsible of that architecture, because yeah, in the slide there are 3 services and 3 reverse proxies, and seems easy to handle. But what if the number of applications or services scale up? What if that number grows up? We may end up with something really difficult to handle, really difficult to monitor, and really difficult to manage. Not only that, we need to configure those proxies backwards compatible with the ones that already exist. Honestly, I don't want to be in that position. So one might think, okay, I've seen this before. I've seen this kind of architecture before. In a distributed system, normally we have, or in other projects, we normally have a control plane or a master nodes that hold responsibility of managing the data plane or the data nodes that do the heavy lifting. So let's do that. Let's place some logic, some brain, some code that handles all those proxies on behalf of us. Let's give some configuration and let's rely on that control plane to control our proxies. Cool. We have that control plane that computes the configuration and pushes that configuration to the proxies, and let's rely on the proxies to do all the heavy lifting to intercept the traffic and do all the TLS termination or whatever we need to. And with this picture in mind, let's define what a service mesh is, because that's what pretty much it is. It's a software that enriches the network layer, usually in a distributed system. And the image already shows it. It's a control plane. It's a brain. It's composed by a control plane and a data plane. The data plane are the proxies that sit next to our applications, our services, our virtual machines, and a control plane that manages them, that pushes their configuration, that controls them, basically. This is a concept. That was a concept. That's a paradigm. But how do we implement this? How do we actually apply that to our infrastructure? There are different solutions in the market, in the industry, and I've just listed 3 of them. This list is not complete by no means. I just listed a couple of them. The first one is Linkerity. They state that they are the ones that coined that concept of service mesh. Another one is Consul Service Mesh, which is designed by a well-known company called HashiCorp, which also designed tools like Vault and Terraform, for instance. And Istio, which happened to be the one I worked with the most, and that's why I'll be providing details about. I would like to note here that the fact that I will be talking about Istio doesn't make me a fanboy or something like that. It's just that when there isn't a best tool for something, right? There's a better fit for a set of requirements. And when we had to decide for a tool, Istio was the one. But that doesn't mean that applies to everybody. And also, with regard to this matter, there's an interesting project called Service Mesh Interface. It's a cloud-native computing foundation sandbox project. What it does, it defines specifically for Kubernetes a set of custom resource definitions. What it does is isolate the configuration we need for our service mesh, isolate that configuration from the implementation of the actual service mesh, meaning that we have our configuration, and regardless whether we use Istio, Consul Service Mesh, Linkerity, whatever, the configuration is still the same. It's a tool that is still in early development, but it's getting quite a traction from several companies. And all right, let's move on. Let's talk about Istio. This project was started and is developed by Google, IBM, and Lyft. It is primarily designed for Kubernetes in mind. It can be extended to virtual machines, but the main goal are Kubernetes infrastructure-based, Kubernetes-based infrastructure. It includes 15 custom resource definitions that already tells you how complex it can get and how many features it provides. It uses Envoy as proxy. You may have used or heard about, I don't know, Nginx, HE proxy. In this case, they use Envoy, which is designed by Lyft, and it's written in C++. And this project is under the umbrella of Google's project called Open Usage Commons, which is a project that manages the trademarks of open source projects, like, for instance, Angular. Angular is also part of this project. And just for the sake of completion, it uses Apache license 2.0. Okay, cool. Let's talk about the features that Istio provide. Another note here, these features are also offered by other tools, Linkerity, Console Service Mesh. I'm just listing them here. And let's depict them. The first one is traffic routing. One might say, hey, Antonio, Kubernetes already solves traffic routing with services and endpoints and other ingresses and whatnot. But Istio adds way more features to traffic routing. You can not only route traffic based on host names, but also headers, HTTP verbs, network protocol. What about load balancing algorithms? If you use Kubernetes or other distributed container architecture, round robin is normally the algorithm, and not only that, you can configure all the algorithms, but it's not as easy as with Istio, with a service mesh. You just need to describe a YAML object, and you're good to go. Your service will be using, I don't know, for example, list connections algorithm. Another cool feature is fault and delay injection. Imagine that you like to answer a question like, how does my system behave when the network is injecting delay, when the network is dropping packages, for instance? You can answer that with this. You can set up a policy or set up a rule saying, hey, my service A that should be contacting service B is now dropping 50% of the packages, or is injecting 5 seconds delay. Let's see how my system behaves on that circumstances. And we can also add timeouts, retries, and circuit breakers kind of logic. For instance, let's set up a policy that say, if service C needs to contact service D and it answers with a 500, let's say, service C should retry 5 times, 6 times. You can also do that. The important thing here is that that kind of logic is not in the application anymore. Again, the application should be responsible of providing value to the project, providing value to the company. And let's rely on Istio, let's rely on Proxy to do features or to provide features that are important for the operators. With regards to security, Istio provides both authentication of the parties involved in communication, or in this case, the services of the virtual machines that are involved in the communication. For example, we can enable mutual TLS in a zero trust kind of network, and authorization of requests. For instance, you can force an application A to only be able to communicate with application B with HTTP post request, for instance. And another nice feature is observability. Because we now have proxies that intercepts all the traffic within our services, or between our services, we have now a holistic view of all what's going on in the network, meaning you can answer questions like, how many HTTP requests have been sent? How many times a service has answered with 200, 300? All those questions, you can start answering them about your system or about your infrastructure. And tracing, because again, you are intercepting all the traffic, it eases the implementation of distributed tracing. In fact, there is a talk later on this day given by Israel from Red Hat, I believe, and I suggest you to attend to it. And actually, I would like to show you a really interesting screenshot here. Yeah, I believe you guys can see it. So because Istio provides a lot of metrics about the network layer, this tool is called Kayali. It just takes the metrics provided by Istio and draws a map of the communication between your services. And think about this. It's really easy to pinpoint a problem because you have all this information at your hand. So imagine you do a request to your application, it creates a change of request, and at some point it fails. Because you have all the metrics of all the network involved in that request, you can pinpoint exactly, oh, this is where it went wrong, or where it got delayed. And okay, cool. How does Istio look like in my infrastructure? Okay, so as I said before, there's a control plane and a data plane. The control plane is a deployment called Istio that reads the configuration we provide. In this case, because as I said, Istio is primarily designed for Kubernetes, it reads a specific custom resource definition. For example, virtual services, destination rules. I won't be showing YAML syntax or configuration or how to configure them, just because obviously the official documentation does a much better job than I would do. And then we have egress and ingress gateways. Those are deployments that are in charge of controlling traffic to and from the service mesh, the cluster, or however you limit your service mesh. And you can think of them as firewalls or network policies on vitamins, because not only you can limit traffic based on IPs or a subnet or a CIDR kind of subnet range, you can also set a policy like, hey, do not let my services access google.com kind of domains, for instance. And I also added a virtual machine there because, as I said, although Istio is primarily designed for Kubernetes, you can extend the service mesh to virtual machines. You can run this Envoy proxy in a virtual machine so that it can connect to our application. For example, for instance, you may have a database running outside the cluster. You can connect it to the applications. And I would like to give more details about what is actually going on here inside the red circle, because it's important to understand that. So let's answer this question. How does my service or a specific service join the service mesh? What is actually going on is that there's a mutating admission webhook that when a pod is created, it intercepts that creation, that YAML definition of the pod, and appends two more containers to the original ones. There's an init container that rewrites the IP tables of the pod so that all the traffic goes to the other pod that it appends, which is the Envoy proxy. And then that proxy gets its configuration from Istio. And I would like to highlight here the fact that the original container, or containers, the application, your application, should not be aware of the fact that it is in a service mesh, or it belongs to a service mesh. That's one of the main goals. What we're trying to do is add more network features without changing the logic of our application. Imagine that I can only speak German, and I'm trying to talk to a person that can only speak French. Normally, we would have a couple of translators, right? And those translators would do the heavy lifting, would translate what I'm saying to the other person. That doesn't mean that I will change my speech. That doesn't mean that I will start speaking in French. I will still be speaking in German, right? The same idea applies here. If the application A should be contacting application B with an HTTP request, version 1.1 on this port and this URL and this path, that shouldn't change. That's the idea here. I would like to also highlight here, this applies, this mutating admission webhook, init container, all that applies because we are talking specifically about Istio, which is specifically designed by Kubernetes. But the idea, it can also apply for other kind of infrastructure. If you had a virtual machine, for example, if assuming we are using another tool that is also designed for virtual machines, kind of the same idea applies. You have your original process, and you normally append a library or another process that intercepts all the traffic. Cool, Antonio, that sounds great. That sounds super nice, but there must be drawbacks, right? And there are, obviously. And I believe the ideas I've listed in the slide applies to every single new tool that we add to our technology stack. Because we are adding a new tool, that means that we need to learn new concepts, new syntax. It's just another variable that can go wrong. Troubleshooting also can be challenging. Why? Because there are a lot of parties involved here. We have us operators that when we configure the service mesh, we can make mistakes. We also have the Istio, the control plane itself. We need to deploy it, we need to monitor it, we need to upgrade it. And we can also make mistakes on that process. And because we are injecting or adding proxies for each one of our services, that means more resource consumption, and not only that, more a performance impact. Why? Because we are adding another layer between our application and the network. It means we need to compute all the traffic, we need to process all the packages, and that means more processing, more time for the requests. Even though there are tests on the internet, plenty of them, that reproduce or try to measure the impact of a service mesh in an infrastructure, with the different tools and Istio, Linkerity, whatever. And normally the results are in the vicinity of milliseconds. But if your application is network fragile, let's say, it depends a lot on the network performance, it may not be, service mesh may not be a solution for you. And okay, what's currently going on in the industry with regards to service mesh and Istio? So we have talked about the resource consumption. We have talked about the performance impact of this. That's why, because again, as I said, we are adding a new layer between the application and the network. Okay, so one might think, Antonio, the kernel already does all of that. It already processes all the packages, right? Yes, and we are kind of using two logics. We are kind of duplicating job here between the proxy, with the proxy and the kernel. Moreover, there is a technology that is getting traction nowadays. I don't know if you've heard of it. It's called Evpf. It allows you to write bytecode, to run bytecode, kernel bytecode, without modifying the kernel itself. Imagine you normally, when you want to run something on the kernel, even you need to add modules, you need to modify the kernel. This technology allows you to, imagine that your kernel has a virtual machine, and you can run simply code there. That's pretty much the idea. Okay, so that sounds cool, right? We have something that can run on the kernel. We have a technology that allows us to do so. Cool, let's mix them together. Imagine that instead of putting the proxy as a different process, we put that logic, or we run that logic in the kernel with the kernel capabilities. That would mean way better performance and less resource consumption. Actually, this approach, I've seen it before named as sidecar-less mesh, and it's getting a lot of traction nowadays. Actually, Istio itself has recently released a project called Bridge to use Evpf to take advantage of this technology Evpf to improve its performance. And for example, another project is called Cilium, which is a network plugin for Kubernetes that also takes advantage of this. And honestly, frankly, it looks really promising. Not only for Istio, not only for Service Mesh, this technology, it looks really promising, honestly. And as the last slide, you probably have already guessed it. The workshop is hiring. We have plenty of open positions from software engineering to management to project management to marketing, you name it. You can find the positions in the workshop.com/careers. And honestly, I'm not getting paid to say this. This is honest. I generally enjoy working with my team, at least the DevOps team, and I am really grateful of being part of them. And actually, honestly, frankly, the market right now, it's really demanding. It's really demanding a lot of IT people. And if I weren't happy there, I won't be there with them. So that reinforces the point I'm trying to make here. And that's all I wanted to say, honestly. Hopefully you found this useful. I really hope so. If not, shame on me. And well, thank you for attending.